Hi, I'm Jem. So the word I'd use to describe 3D printing is revolutionary. It's changed the way we prototype and design products. And I'd also like to use that word with regards to human tissue or human bodies. What we're doing is we're producing the hardware that allows those researchers to print human tissue. It's working tissue engineering. And the reason I got into it was because when I have a variation in my biology that meant I couldn't have children. I found there's a lot of people just like me, and I was kind of interested in finding out a way to actually fix that problem. I also came across a lot of friends who had missing fingers and issues with their body as well that surgery just couldn't fix. Oftentimes surgery actually doesn't make things better, it can often make things worse. So one way around this is by actually by growing a tissue outside of your body and putting it back into your body works much better. So what happens is a lot of researchers are actually using equipment called bioprinters at the moment to grow human tissue, to print human tissue outside the body for implantation into the body. However, the problem with more expensive they are. However, so a lot of promising researchers can't get into this area because it's just too expensive. So what we're doing is we're building something that's affordable for most researchers, for a PhD student, for biohackers, that has that kind of accuracy but at a price that they can afford. So I got started 4 years ago, and I sold a couple of my businesses while I was doing my master's degree. And I built my own printers on my kitchen table. And I started building my own bioprinters and trying out different experiments and seeing which ones worked and which ones didn't. I then tried printing in liquid, so mimicking what you would find inside a human body. So pretty much like creating an artificial womb. I also printed fingers as well for my thesis, partly because the university cut my funding. So I decided scientist gives the university the finger. So they still gave me a B for it. So anyway, later on they actually gave me some funding again. So I went on and realized that accuracy is really important, that you can control the cell growth by making things more accurate. So we built these more sophisticated printers, and we took it down to 10 microns, and that's where we are today. So to do this, we need a really strong engineering team. And my background is in physics and nanobioscience. And Alana is our software developer, and Joe is our mechanical engineer. So where we are at the moment is we have a printer that is 10 times more accurate than what you would find at the same price. In fact, for some printers are 2 or 3 times more expensive and don't even have the same accuracy. So we wanted to build something that researchers wanted, that was reliable, solid, upgradable, and So where we see ourselves in terms of the market is that there's over 10,000 universities across the world, at least that many universities, and there's a lot of bioprinting papers being published at the moment because it's a pretty hot area, because they do know that it works very well in terms of tissue growth. There's also over 400 hacker spaces and a growing number of biohacker spaces, fueled in part by the interest in synthetic biology. So we want to provide the hardware, affordable platform for all these places to use. We want all the students there, all the biohackers, citizen scientists, everybody to use this equipment. We want to democratize bioprinting. So where we're at the moment is that we're filing our own patents. We're talking to investors. We're selling machines, and we're also applying for grants. We're also looking for more partnerships in terms of developing the hardware. So we want to start getting into printing the actual stem cells and start doing more of the actual process. So we're interested, if anybody's interested in talking to us a bit more about it, we'd be happy to chat with you afterwards. Thank you very much.